Welcome back to another video. In this video, we are going to be talking about applications of solving right triangles. If you watched the last video, I walked you through how to solve a right triangle, which means you find the length of every side of the right triangle and the measure of every angle of the right triangle. In this video, we're going to look at some real life applications of where you will want to solve a right triangle. Except whenever you have a real life application, you might not necessarily have to find the length of every side and the measure of every angle. You may just have to find what it is you're looking for. So we're going to look at some examples in a minute. But before we look at some examples, there are two terms that we need to know that are usually used a lot in solving right triangles. And the first one is the angle of elevation. This is basically from a point X to a point Y. It forms the acute angle by ray XY and a horizontal ray with endpoint X. So basically, you have this. Let me get my laser here. You have this horizontal ray with an endpoint X. You have this other ray XY. Notice that Y is a point above X. And it's that acute angle that's formed from going to this first ray to the second ray. It's an angle that's going up. So angle of elevation, as you can probably, imagine elevation means to go up. It is the measure of the angle going up from those two rays. And on the other opposite end of that is the angle of depression, which is from a point X here to a point Y here. Now notice that Y is below X. It's the acute angle that's formed again from a horizontal ray with endpoint X to the ray XY. So now this is the angle that's going down. It's an angle of depression. So elevation means to go up. Depression means to go down. So just like you would think, when you hear those terms up and down, depression, elevation, and depression, that is those angles that we will be talking about in some of these problems, the angle of elevation and the angle of depression. All right, so now there are 3 steps to solve and apply trigonometry problems. The first thing you always want to do is you want to draw a picture. You want to draw a picture, you want to label it with the information that's given, and then any unknown variables or quantities, you want to label those with variables. Alrighty, so anything that's unknown, you want to label it with a variable. A X or a Y, a little a, or a capital A. Whatever is missing, you can label it however you want to, really. And then the second step is you want to use the sketch to write an equation that relates the information that's given to the variables that's unknown. And then once you have those equations written, you want to solve those equations and check your answer and make sure it makes sense. So those are the 3 steps that we'll go through to solve these applied trigonometry problems. And so we're going to look at a couple examples. So let's just get started. For this first example, Shelley McCarthy knows that when she stands 123 feet from the base of a flagpole, the angle of elevation, there goes that term, angle of elevation to the top of the flagpole is 26 degrees and 40 minutes. If her eyes are 5.30 feet above the ground, find the height of the flagpole. Okay. So the very first thing we want to do is we want to draw a picture. And so I'm going to do my best here to sketch a picture. So we have Shelley over here somewhere. Here's my little stick figure. Shelley is standing, and she's standing 123 feet from the base of a flagpole. So I'm going to draw a little flag here. Here's our little flag. So she's standing 123 feet away from that flagpole. All right. Now, it also says that the angle of elevation to the top of the flagpole is 26 degrees and 40 minutes. And it says if her eyes are 5.3 feet above the ground, find the height of the flagpole. So it tells us that her eyes are 5.3 feet above the ground for a reason. So I'm going to imagine her eyes are here, and I'm going to draw a line from her eyes to the flagpole. And I know that distance from the bottom of the flagpole to that line right there is 5.3 feet. And notice it gives it to us as 5.30. That is 3 significant digits. If you look at 123, that's 3 significant digits. And 26 degrees and 40 minutes, remember when it was in either minutes or seconds and it was a 0 at the end, you didn't count the 0. So that's also 3 significant digits. So that means any answers we get, we're going to give them in 3 significant digits. Now, angle of elevation. So remember, elevation goes up. So that means that's the angle that's formed from taking that horizontal ray to that ray that has a point at the top or above the X. So our X represents the person, Shelly. So our Y will be the top of that flagpole. Alrighty. And so that angle of elevation will be this angle here, which is the 26 degrees and 40 minutes. Now, if you convert 40 minutes to degrees, that gives you a repeating decimal. That's 26.6 repeating degrees. Alrighty. You would do 40 divided by 60 to convert that to degrees. So now what we want to know is, instead of us finding every angle and every side, we only want to know the length of the flagpole. So I basically want to know this length right here. Okay, from here, this 5.3 feet to the top of the flag right here. Okay, and so I know that this is 26.666 repeating degrees. I know the length of this side here is 123. So if I use this angle and this side, this will be the adjacent side. And I want to know what is the opposite side of that angle. So I have the adjacent side. I want to know opposite. So the trigonometric function that uses opposite and adjacent is the tangent function. So I'm going to use the tangent and of the angle that we have, the 26.66666 repeated degrees, that's going to be equal to the opposite side, which we're going to let equal a variable x, because we don't know, little x, we don't know what it is. So it's going to be x over the adjacent side, which is the 123. So now if I want to solve for x, I multiply both sides by 123. And so I end up getting x is equal to 123 times the tangent of 26.666666666 repeating, remember, degrees. And if you plug that in your calculator, 123 times the tangent of 26 point, and then just write as many sixes as you can, or just a lot of them, and you get 61.7729. So you get approximately 61.77292175. But remember, everything here has 3 significant digits. So if we round that, so this little curly equal sign means approximately. So if we round that to 3 significant digits, that would be 61.8. So our x over here is 61.8. Now, that's not the complete height of the flagpole, because we have to also take into account this 5.3 feet here at the bottom. So the height of the flagpole would actually be the 61.8 plus the 5.3. So if you add those two together, the 61.8 and the 5.3, you get 67.1 feet. So the height of the flagpole would be 67.1 feet. Alrighty. So that is how you will solve that problem. Okay. If you have any questions about it, don't hesitate to put them in the comments below and I will respond. Let's look at another one. Alright, for this one, example 2, it says the length of the shadow of a building 34.09 meters tall is 37.62 meters. Find the angle of elevation of the sun. Okay, so I have a little drawing of a building on here. I have the sun over here that's shining. I'm just drawing these little lines so you can see the rays of the sun. When the sun shines down, it casts a shadow that is going to fall this way. Cast a shadow that falls this way. We know the length of the shadow is 37.62 meters. So what we're doing is we're establishing our picture. Well, the sun shines and it creates a right triangle, basically, with the angle of elevation, with the length of the shadow and the height of the building. So the height of the building is 35.09. So we know this side is 35.09. So that angle of elevation would be here. It's the angle that's going up. And so that is what we're looking for. We'll call this side over here A. So we're looking for the measure of angle A, the angle of elevation. Now, we know if this is angle A, we know the side opposite of A, which is here, and we know the side adjacent to A. And so again, if we think about which trigonometric function uses opposite and adjacent, again, that is the tangent function. So we would say the tangent of A is equal to the opposite side, 34.09, over the adjacent side, which is 37.62. And so now we know what the tangent is, but we don't know the angle. And so remember, whenever you want to solve for the angle, you have to use the inverse function. So we would say A is equal to the inverse tangent of 34.09 over 37.62. Also notice that our measurements are given with 4 significant digits. So whenever we find our answer, we will give it in 4 significant digits. So plug this in your calculator, inverse tangent, 34.09 divided by 37.62. I'm plugging it in right now just to make sure I get the same thing I got from before. And I get 42.1818299999. All right, but I want to do 4 significant digits, so I will stop after the 8. So measure of angle A will be 42.18 degrees. And remember that A was our angle of elevation that we were looking for. So we will stop right there. That would be our final answer. Okay. If you have any questions about this problem, please don't hesitate to put them in the comments. And again, I will respond. Okay. I finished right on time. My battery about to go dead. Alrighty. So thank you all for watching this video. If it helped you, go ahead and hit the like button. And if you haven't already, go ahead and subscribe to the channel. I thank you again for watching, and I will see you in the next video.